Welcome back. Today we're going to be doing another related rates question. We're going to be doing the classic question about the shadow. Okay, a street light is mounted 15 feet high. A 6 feet tall person walks away at 5 feet per second. Part A asks how fast is the shadow lengthening when 20 feet from the pole, and part B asks how fast is the tip of the shadow moving. Okay, so we'll talk about how to answer both those questions today, but first I'm going to write out what is given here. So we have a street light that is 15 feet tall. So here's our street light right here. All right, then we have a 6 foot tall person that's walking away at 5 feet per second. So the person is 6 feet tall and they're walking away, so say this way, at 5 feet per second. All right, from the moment when the person is 20 feet from the pole, right? So we're looking at the moment when, let's move this over, when we're a bit further away, right? When this distance here is 20 feet from the pole, we want to know how fast is the shadow lengthening and also how fast is the tip of the shadow moving. Okay, so first of all, what do we know here? Well, we know that dx over dt is equal to 5, right? Because the rate of change of x with respect to t, the time, would be 5, right? It's 5 feet per second. Then we need to find the length of the shadow. So let's let s be the length of the shadow. So I'm going to write that down. Let s be the shadow length. And therefore, x plus s would be the distance from the pole to the tip of the shadow. Okay, so the first thing I'm going to do is we need to set up a relationship using similar triangles. So we know that the height of the person is 6, and that the height of the person over length of the shadow is going to be equal to the length of the pole over x plus s, right? The distance that they've walked away plus the length of the shadow, right? And so then if I cross multiply, I'm going to get that x plus s over s is equal to 15 over 6. And we want to solve for s here. So in order to do that, let's actually multiply, cross multiply, divide. So that means 6x plus 6s is equal to 15s, which means that 9s is equal to 6s, x, and therefore s is equal to 2/3 x. Okay, great. Now we have s in terms of x, which is what we need. Next, I'm going to be differentiating both sides here with respect to time. So I'm going to be taking this equation and we're going to differentiate here. So ds over dt is equal to 2/3 times dx over dt, right? Because when we take the derivative of 2/3 x, that becomes just 2/3, right? Via the power rule. All right, and then next I'm going to sub in what we know. So we already know that dx over dt is 5, right? So therefore ds over dt is going to be 2/3 times 5, which is 10 over 3. So therefore it's 10 over 3 feet per second. And so that's part A all completed. Part A's answer is 10 feet per second. Okay, now what about part B? So for part B, we want to know the tip of the shadow specifically, right? How fast is the tip of the shadow going to be moving as the person walks when they're at that 20 feet point? Okay, so for this one, it's going to be d over dt of x plus s, which is equal to dx over dt plus ds over dt. And that is equal to 5, right? We know that 5 is dx over dt plus 10 over 3, and that's going to be 25 over 3 feet per second. And so that's the answer for part B. So the great thing is once we have part A, doing part B is actually not so terrible. All right, but as always, if you do have any questions, feel free to leave those down in the comment section, and we'll see ya for the next one.